So this one, I think I have 3 problems total, just reviewing different ways to apply the derivative rules, and I'm just going to quickly show you the rules that you learned. These are coming from Refutable. These are all the rules that you should know from top to bottom, starting with the basic rules that you probably have memorized. Then we go into the 6 trig rules. At the bottom, numbers 11 through 13, and then 14 through 16. Then 17 through 22 are your inverse trig rules. Notice that there's only 3 that you have to memorize, but sine and cosine use 1 minus u squared, but secant and cosecant use u squared minus 1. That's the difference. And then the exponential rules. If you want to memorize the log rule, it's sitting right here. You'll notice I usually do a change of base. So going back, when you're applying your derivatives, you should know how to write the equation of a tangent line. And the equation of the tangent line, number is y minus y1 is equal to m times x minus 1. If I tell you write the equation line at x equal to 5, then this right here better be a number, not an equation. Some of you keep doing that. If I ask you to write the equation of a normal line, it looks almost exactly the same. Y minus y1 is equal to the only difference, opposite, reciprocal. You should be able to find where 2 functions are parallel in terms of their tangent lines. So if I ask you to find where the 2 functions f and g have parallel tangents, that would be where the derivative of f is equal to the derivative of g, because that would make their tangent slopes be the same. And then number 4, if I ask you to find perpendicular, very similar to what you did a second ago, only now, instead of taking the derivative of f and making it equal to the derivative of g, perpendicular slopes are opposite reciprocals. Okay? Number 5, finding horizontal tangents. That's where your derivative is equal to 0. Finding where the derivative is equal to a certain value. If I said find where the derivative has a slope of 5, that would be the k value. So those are all different examples of applying derivatives. So, first question, write the equation of the normal line. So go ahead and press pause, do the problem, and then you can look at the answer. So, starting off, equation of the normal line, I'm going to do the point, which I have 3 pi over 4. And I don't know the y value yet. I need the slope. The slope we get by finding f prime of 3 pi over 4. Those are the pieces of information I need to find. So, starting with the point, let's do f of 3 pi over 4. That's 4 to the tangent of 3 pi over 4. So I need the tangent of 3 pi over 4, 3 pi over 4, second quadrant, tangent's negative. Tangent values for pi over 4s are always 1. So this is negative 1, which is 1/4, not negative 1/4. The next piece I'm going to need is the derivative. The derivative of a to the u would be a, which is 4, to the u, ln of a. So that's the derivative of the outside. Leave the inside the same. Multiplied by the derivative of the inside, which is secant squared of x. So now the only piece I gotta do is find the derivative at 3 pi over 4. 4 to the 3 pi over 4 we already found, that's 1/4. ln of 4 secant of 3 pi over 4 whole thing squared. So secant of 3 pi over 4, let's do that right here. That'll be here, secant will be negative here. The cosine value is root 2 over 2. Therefore, the secant value, let me write back everything else, the secant value would be 2 over root 2 squared. So we get 1/4 ln of 4 times 4 over 2, which is 2. Therefore, we get 1/2 ln of 4, and I'm going to write that as 1/4 fraction, ln of 4 over 2. So there's my derivative. I have everything I need, so now I can write my equation of the normal line. Y minus 1/4 is equal to opposite reciprocal of the slope times x minus 3 pi over 4. Okay? There's your answer. Next question. Press pause. Find the point where the function is parallel, so my key is parallel. So I'm going to find f prime of x, which is 1 over u. So that would be leave the inside here, times the derivative of the inside, which simplifies to 1 over x. This one here, g prime of x is equal to x, and then I want to find where these two functions have the same slope. So I get x squared is equal to 1, x is equal to plus or minus the root of 1, which is 1. Now, you would think that both of the answers work, but we actually have a restriction because of ln, and because I asked you where the point is, or points, you'd figure out that there's a restriction anyway. If I asked you what are the x values, you'd probably get this problem wrong. So, a good hint is anytime you see an ln problem that you're going to work with, I actually find the domain of ln problems. So the domain is ln. You always take what's inside the ln, set it equal to 0, x is equal to 0, and then you do a sign chart for 4x. This is an easy sign chart. So at 0, 4x would be 0. If I pick a number negative, it'll make 4x negative. If I pick a number positive, it'll make 4x positive. And then you ask yourself, ln only picks positive numbers, so the domain is 0 and greater. What that means is I can tell that the only answer as a result of ln would be positive 1. You would figure it out another way if I ask you the points, because you'd have to substitute back in. So if I substitute back into, either of the functions, it would be the same x value that you get. I'm not going to use this one because this guy has the restriction. So over here, if I try to find the f of 1 value, I would get the ln of 4. If I tried to find f of negative 1, I would be looking for the ln of negative 4, which doesn't exist. Therefore, the only point is 1 comma ln of 4. So that's the point on the f of x function. I'm just realizing normally I wouldn't ask you for the points. I would ask you for the x value. The reason is because the x value is the same for the functions, but the y values are actually different because you're not intersecting the two curves. So just real quickly, if I just showed you, I'm not going to make the exact graphs, but ln of 4x would look pretty much like this. And then plus 3, 1/2. It looks something like this. And so at a specific x value, you'll get parallel, let's say about here. We'll say that's about the same x value. But what you'll notice is the y values are different. So on the ln curve, this is the y value, but you'll notice on the g of x parabola, the y value would be different. So I probably wouldn't ask you for the points, I'd ask you for the x value, and the x value is only positive 1. If this is a multiple choice question, I guarantee you that your choices will be 1 would be a choice, and then the other choice that's close would be plus or minus 1, and this would actually be incorrect. So again, just a reminder, if you see LN problems, you should find their domains. And over here is how you do a domain of LN. You do a little sign chart for the inside. Next problem, go ahead and press pause. I'm just asking you to find the derivative. So pause. Alright, so cosine would be negative 1 over the square root of 1 minus squared. So that's the derivative of the outside. Leave the inside times the derivative of the inside. So let's clean this up a bit. And I'm actually going to square that out. And the reason is, it's not simplified right now. That 4 tells me that there is a square root, a perfect root hiding inside the square root, so I'm going to simplify it. So I'm going to get a common denominator of these guys. Which would be 4 over 4 would be what I multiply this guy by. So I get 4 minus x squared all over 4. But that can be simplified some more. That would be the root of 4 minus x squared divided by the root of 4, which happens to be 2. I get negative 1 over the square root of 4 minus x squared, and no, this does not simplify anymore unless you're trying to factor it. In that case, we could write it factored. 2 minus x times 2 plus x. Okay? Last question, I think. Go ahead and press pause. So, similar to a problem you've had in the book, you want to find where f of x intersects the x-axis. Those are x-intercepts. X-intercepts occur when y is equal to 0. So, you actually have to start off by figuring out the point that they want you to write the equation of the tangent line. So, you're trying to figure out where the inverse function has a value of 0. So, the inverse function is a little bit backwards. This is a value, and this is the angle. So really, this question is asking you, given the quadrants you're allowed to use for cosine, which are only first and second, cosine inverse only allows you to use those quadrants. The angle of 0 would be here, so the value that you get is actually also 0. So then x over 2 has to equal 0. Value meaning if the angle is 0, oh actually sorry, the value is 1. Wow. I made the problem, I don't remember. So this is the angle, and this is the value. And the confusion is because I'm using the inverse function, so they're backwards in the statement. If this was cosine of x over 2, then this would be an angle. But since it's cosine inverse, the angle and the value switch places. So if the angle is 0, the value is 1, so therefore I get this, therefore x is equal to 2. So if I restate the given information, the cosine inverse of 1 equals 0 is the same statement as the cosine of 0 is equal to 1, because inverses mean switch your x and y's. So this is a true statement, and this is also the true statement. So now I'm just trying to find the equation of the tangent line at that point. So I'm actually going to seal this one more time and move it to the next page. So we figured out that the point is where x is equal to 2. X is equal to 2. How about 0? So, we already found the equation, the derivative that was negative 1 over 2, square root of 4 minus x squared. So all I have to do is write negative 1 over 4 minus 4 square root, and we get undefined. Now, the point exists, and what's going on is the fact that the derivative does not. So you pretty much have a cusp, corner, or vertical tangent occurring, if I didn't make a mistake here. So the equation of the tangent line, because we know it exists, it is a vertical tangent. So vertical tangents are vertical lines, and vertical lines are all written the same way. This is actually the equation of the tangent line. The equation of the normal line would be y equals 0, because that would be a horizontal line. Tangent, normal.